Hey guys, welcome to my YouTube channel. I'm delighted to have you guys join this class today, and I'm here to break down this question easy step because math is simple, math is easy, and math is what enjoyable. So follow me and let me show you how to solve this in under 2 minutes. Okay, when you're given a question like this, let y to be equals to x squared over exponential x. What method can you use to solve this? This is simply using quotient rule. Quotient rule. Identify the method to use in solving differential equation. Differential calculus is very what important, because if you don't identify the method to use to solve, you're going to what fall under wrong answers. Okay, now let's solve this together. If you're given y is equals to x squared over exponential x, you're going to use quotient rule. And what does quotient rule state? This is quotient rule. What does quotient rule state? Quotient rule simply state that v du dx minus u dv dx all over v square. Here again, your choice of u is very important. You have to know the choice of u before you actually solve this. Okay, now I also told you guys you should always put late like 8. Okay, I always put late that our L stands for logarithm, our A stands for algebraic, and our T stands for trig function, our E stands for exponential function. When you have a logarithm function, your choice of u will be that logarithm function. If you don't have a logarithm function, you have an algebraic function, choice of u will be that algebraic function. Okay, now let's solve this under what 2 minutes, or just under a minute. It's very simple. Let's solve this solution. A quick one, guys. So now y is equals to x squared over exponential x. How do we solve this? Very simple. Now we'll say let our u be equals to x squared, because based on this late, we don't have a logarithm but have an algebraic. So our choice of u will be x squared. So that when you differentiate this, I have our du respect to x. Differentiating this, to simply, this is 2 multiplying by 1. Okay, so the power of x here is 2. We'll come down, multiply the coefficient of x. The coefficient of x here, which is what? 1. So 2 times 1, then you subtract 1 from the power of x. So x2 minus 1 going to give us 2x. Okay, so that our du dx is what? 2x. Now we say that our v, so let our v be what? Our v be what? Exponential x. Now, so that our dv with respect to x will simply be what? Exponential x. Whenever you're differentiating exponential x, is still exponential x. It's a standard derivative. Okay, it's standard derivative. Now, since we have our u, we have our du, we have our v, have our dv, we simply impute all of this into what? The formula, which says v du dx minus u dv dx over v squared. So we're going to have this to be, our v here is what? Exponential x multiplying by du, which is what? 2x, minus our u is what? X squared, multiplying by dv, which is what? Exponential x, all over v squared. And our v is exponential x, so exponential x all squared. All right, now let's simplify this further. We have this to be equals to, we have this to be 2x exponential x minus x squared exponential x all over laws of indices. When you have a to the power of m or to the power of n, this is simply what? A to the power of what? Mn. Laws of indices. Now simply you have exponential x all to the power of 2. This is simply exponential 2x. Okay, because you multiply 2 times exponential 2x. Okay, so that we have this to be 2x exponential x minus x squared exponential x all over exponential 2x. Okay, now for the numerator, what is common? We have this to be, what's common here? Exponential x. So we further exponential x outside, so we have this to be 2x minus x squared all over exponential 2x. Now, okay, exponential 2x. Can you say that? Can you stop here? Can you stop here? You see that exponential x is outside, exponential x is outside. You have 2 exponential x. We can have this to be 2x minus x squared over exponential x. Okay, as our final answer. So this is our final answer. Is 2x minus x squared over exponential x as our final answer. If you love this video, I'll see you guys in the next video. Okay.